Imagine a ship built not with the limitations of today's technology, but with the boundless dreams of human imagination. A vessel designed to accelerate without end, its engines drinking from an infinite reservoir of fuel, pushing harder and harder against the dark silence of space. At first, the progress seems ordinary, just like a jet crossing the sky or a rocket escaping the pull of Earth. The crew feels the steady pressure of acceleration, their instruments showing speed climbing higher with each passing moment. They glance at the stars ahead and think perhaps they will one day reach them, not in centuries, but in months or even days. But something strange begins to happen as their speed grows. At half the speed of light, distances contract in front of them, the star fields squeeze together, the colors shifting into a harsh brilliance. At 3/4 of the speed of light, the engines roar with unimaginable power, yet each extra push grants less reward. The universe appears to stretch its own invisible hands to resist their attempt. By the time they reach 9/10 of light speed, the ship is caught in a cosmic illusion. From the perspective of those aboard, everything outside seems to be racing faster than ever. But to an observer watching from Earth, the story is different. The ship's clocks tick slower and slower. A second on board no longer matches a second on Earth. Minutes become hours, hours become days, and the ship falls into a kind of temporal quicksand. Time itself has begun to bend beneath the weight of their velocity. Now imagine them at 99.99% of the speed of light. The mass of the ship appears to increase, as if the very atoms are growing heavier under the strain. Each atom of hydrogen in the fuel requires more and more energy to give the same small push. The closer they creep toward the ultimate limit, the more the universe seems to conspire against them. Energy poured into the engines does not translate into proportionate speed. It translates into resistance, into weight, into the slowing of time itself. The travelers would see the stars ahead compressed into a dazzling tunnel of light. Radiation from the cosmic microwave background, normally invisible to human eyes, would be shifted up into deadly beams. The hull would be battered by particles that, at these speeds, strike with the fury of bullets. To survive even a few minutes at this velocity would demand shielding thicker than mountains. The dream of effortless travel begins to feel like a nightmare of endless opposition. What they do not yet realize is that this is not simply a challenge of engineering or survival. It is not a question of building stronger walls or larger engines. It is a law written into the very architecture of reality. The speed of light is not just fast. It is not merely a number that can be outpaced with enough power. It is a horizon that no amount of cleverness or ambition can cross. To push against it is like trying to reach the end of the rainbow. Each step forward only makes the goal retreat farther away. Picture the crew staring at their instruments as the engines burn brighter than any Sunday. They see their velocity creep closer and closer to that sacred constant, yet never reaching it. 99.999, 99.9999, always adding another 9, but never the final step. Each decimal place demands not just more fuel, but a leap in energy that surpasses imagination. Soon the requirement outpaces the energy bound inside, stars themselves. And if they could somehow reach the very edge, what then? At the exact speed of light, time for them would stop entirely. The concept of before and after would dissolve. Their mass, as far as any outside observer could measure, would become infinite. No structure, no matter, no particle with rest mass could endure such a transformation. It is a wall sharper and stronger than any made of stone or steel. It is a barrier not of matter, but of principle. This is the cosmic pushback. The universe itself says, you may move, you may accelerate, you may explore, but you may never cross this final threshold. The limit is not arbitrary. It is not negotiable. It is woven into the fabric of space-time itself. To reach the speed of light would mean tearing apart the rules that make reality coherent. It would mean breaking the logic of cause and effect, unraveling the threads of space and time. The thought experiment ends not with triumph, but with awe. The ship can chase the light forever, but it can never become it. Each new fraction of progress demands sacrifices greater than any civilization could supply. The engines may roar for eternity, but the limit will remain untouched. And so the universe guards its secret. Beyond that invisible line lies not a prize to be won, but a truth to be understood. The barrier is not there to deny us. It is there to remind us that reality is built upon laws deeper than desire. The speed of light is not just a fast number. It is the skeleton of existence itself. The reason lies in the strange and elegant framework that Albert Einstein uncovered more than a century ago. It is not simply about speed, or about light, or even about motion. It is about the very way the universe stitches space and time together into one inseparable whole. And it is within that woven fabric that the ultimate limit is hidden. The ship continues its endless acceleration, its crew now trapped in a paradox of perception. To them, each burst of thrust feels like progress, yet the outside universe insists otherwise. Signals sent home take longer and longer to arrive, not because the distance is too great, but because time itself is refusing to march at the same pace. To their families on Earth, decades slip by, while only years pass on board. In this way, speed becomes not just about motion, but about the bending of reality itself. The ship is no longer only a vessel, it is a laboratory inside which the rules of the cosmos reveal their most hidden laws. Imagine standing at the observation window of this ship as it slices through the interstellar night. The starlight ahead has turned into a needle of blinding radiance, while behind, the sky stretches out into darkness. The crew finds themselves in a universe distorted by their own motion. If they were to open a physics textbook, they would discover that the equations had predicted this all along. They had whispered of the way time stretches and space contracts as one approaches the cosmic limit. Now those equations are no longer theory but living experience. The further they press, the more the weight of existence itself resists them. It is as if they are trying to climb a mountain with no summit. Each step brings exhaustion, yet the peak recedes ever higher. The engines scream, yet the ship inches forward with diminishing returns. This is the law of relativity, revealing itself not as an abstract principle, but as a palpable, crushing wall. It is the wall of infinite energy, the wall that no star, no explosion, no fusion reaction can ever supply the power to breach. And still they press on, because curiosity is stronger than fear. Their instruments now show energies greater than what fuels galaxies, yet the final goal mocks them. To them, it feels like nearing the finish line of a race that is always one step farther. Every calculation shows the same result. Approaching the speed of light is possible, reaching it is not. The paradox deepens when they consider what it would mean if they could somehow succeed. To move at the speed of light is to abandon the flow of time itself. Photons, the particles of light, do not experience past or future. To a photon, there is no journey, only an instantaneous existence between emission and absorption. If the ship were to match this, its story would end in a single frozen moment. No motion, no change, no life could exist at that point. For beings made of matter, the speed of light is not just unreachable, it is uninhabitable. Outside the ship, astronomers on Earth continue to watch. They see the vessel's progress stall, not in terms of distance traveled, but in terms of the march toward the ultimate limit. They record how the clocks on board slow nearly to a halt, how signals stretch into eternity. They realize that the ship has become a demonstration of the universe's most sacred covenant. The closer one comes to the barrier, the more the universe reveals why it must never be crossed. The crew begins to feel the weight of this revelation. Their ship is still accelerating, yet the truth is undeniable. They will never become light. They can only chase it, endlessly, asymptotically, forever reaching closer, but never touching. The closer they draw, the more reality itself bends to ensure they cannot arrive. The ship becomes like a moth circling a flame it cannot touch without ceasing to exist. And yet, there is beauty in this impossibility. The very laws that hold them back are also the laws that hold the stars in their courses, that allow galaxies to form, that preserve the chain of cause and effect. If the speed of light were not an absolute barrier, the universe would collapse into chaos. Signals could outrun one another, effects could precede causes, and the very meaning of time would unravel. What appears at first as a prison is in truth the scaffolding of existence. As the crew sits in the dim glow of their vessel, they realize that their journey has transformed from exploration into revelation. The barrier is not simply a line they cannot cross. It is a message written into the structure of space-time itself, a message that says, "This far you may go, but no farther." Beyond lies, not a realm to be conquered, but the foundation of reality itself. The dream of surpassing light speed is as old as the first spark of human wonder. It is the dream of reaching distant stars, of outrunning time, of grasping infinity. But the cosmos does not bend to dream alone. It demands understanding. It demands respect for its laws. And in those laws lies a deeper truth. The barrier is not an enemy, but a guardian. It keeps the universe from unraveling. It keeps time from devouring itself. And so, though their engines still thunder, the crew understands the meaning of their voyage. they have not failed. They have discovered why success was never possible. They have seen with their own eyes that the barrier is not an illusion, but an eternal truth. The speed of light is not merely fast. It is the spine of reality, the rule without which nothing could exist. The story of their journey ends with silence, as the ship continues to race into the night, always accelerating, never arriving. The universe has given its answer, and in that answer lies the beginning of a greater story, the story of how space and time themselves are bound together, and why the speed of light is the thread that ties them. It is in this story that Einstein's insight takes center stage. The barrier is not only about speed, it is about the union of space and time into one fabric, where light's velocity is not a limit imposed from outside, but a constant woven into the structure of existence. The ship drifts on, not in stillness, but in a perpetual pursuit. Its crew has become part of a cosmic parable. They know now that what they face is not simply friction or resistance. They are confronting a principle written into the foundation of reality. Every new burst of acceleration pushes them closer to light, yet also deeper into strangeness. The very structure of space contracts before them, and time stretches behind. They are not just travelers anymore, they are witnesses to the most profound of laws. From within the ship, the experience feels both exhilarating and haunting. Windows that once framed familiar constellations now reveal a warped tunnel of light, as though the stars themselves are rushing into a single, luminous point. The blackness behind them grows heavier, swallowing more of the universe into a void. If they peer closely at the particles that bombard their hull, they realize they are encountering ordinary atoms of space dust. But at these velocities, each one strikes with the ferocity of a warhead. The closer they approach the limit, the more hostile the cosmos becomes, as if it is warning them away from the forbidden edge. The crew debates among themselves. Could there be a clever trick to slip past the wall? Perhaps if they angled their acceleration differently, or used light itself as propulsion, or found some yet unknown loophole in physics. Yet every calculation points to the same truth. There is no trick. There is no escape. The wall is not an obstacle within the universe. It is the framework of the universe. To cross it would mean ceasing to exist as matter. They turn to their instruments and see the numbers growing absurd. To gain just one more fraction toward light speed requires more energy than their entire civilization could produce in its lifetime. To gain another fraction after that would require the energy of all the stars in the galaxy combined, and beyond that lies the impossible demand, infinity. To reach the exact speed of light, they would need infinite energy. Infinity is not simply large, it is unreachable. It is the signature of impossibility. This realization falls heavy upon them. Their ship, their mission, even their hopes are pressed against the unyielding boundary. Yet in that weight, there is also a strange sense of wonder. They are seeing not the failure of their dream, but the majesty of the cosmos. They have found the edge, not of space, but of possibility. It is an edge sharper than any blade, an edge that divides the knowable from the impossible. The truth becomes undeniable. The universe is not merely resisting their speed, it is preserving its own logic. If they could move faster than light, signals could race ahead of causes. A message could arrive before it was sent. A person could appear at a destination before they had even departed. Time itself would collapse into paradox. The barrier they face is not only a limit of energy, it is a shield protecting the coherence of reality. They are humbled by this. The ship continues, but their minds turn inward. They see that the barrier is not a punishment. It is a law, as sacred as gravity, as profound as the existence of matter itself. The speed of light is not only the fastest any particle can travel, it is the boundary that keeps cause and effect intact, that holds the universe in order, that allows the flow of time to have meaning. The silence of space outside mirrors the silence of their realization. They have chased the light to its edge and discovered not an open door, but an eternal wall. Yet they also know that in touching this wall, they have brushed against the truth of the universe itself. The speed of light is not a number on a chart. It is the architecture of reality, the pulse by which the cosmos beats. And so, their journey becomes not an effort to break the barrier, but to understand it. They see that Einstein's insight was not simply about speed. It was about the fusion of space and time into a single fabric, a fabric in which the speed of light is the constant thread. They realize that their story is not ending here. It is only turning a page into a deeper revelation. The thought experiment of the endlessly accelerating ship closes with this understanding. The crew will never outrun light. But in trying, they have revealed why the barrier exists and why it must remain. The limit is not a cage, it is the spine of existence. Without it, everything would collapse into chaos. With it, the universe can stand. The next step is to leave the ship behind and turn our gaze to the deeper truth that holds it in place. To understand why the barrier cannot be broken, one must look not only at speed, but at space-time itself. For here lies the real secret, the rulebook of the cosmos, the fabric that makes motion, time, and distance possible. And so the story continues into the strange and beautiful logic of relativity, where space and time are no longer separate, and where the speed of light is revealed not as a prison, but as the very law of existence. To understand why the speed of light is the ultimate barrier, we must step beyond the story of ships and engines and into the very fabric of reality itself. Space and time, the two arenas in which all motion and all existence play out, are not the separate stages we once thought them to be. They are threads of the same cloth, interwoven so tightly that one cannot be pulled without tugging on the other. This was the revelation that Einstein brought to the world, a revelation that shattered centuries of assumptions. For most of human history, space was imagined as a vast emptiness, a stage across which objects moved, while time ticked in the background, steady and universal. A clock on Earth and a clock on Mars were thought to keep the same beat, regardless of how the planets moved. But the discovery of relativity overturned that ancient picture. Time does not march equally for everyone. Space does not remain fixed in its shape. They bend, they twist, they flow together, all according to the movements and energies of matter within them. The speed of light emerges here, not as an arbitrary number, but as the stitching that binds space and time together. It is the conversion factor between distance and duration, the single quantity that tells us how many meters of space are equivalent to 1 second of time. This is why every equation of relativity is written with light at its center. It is not because light is special in itself, but because light travels on the very boundary of what is possible within the structure of space-time. Imagine space-time as a vast sheet stretched taut. Every object with mass presses into it, curving it slightly. Planets bend it, stars bend it, even the smallest pebble bends it, though only faintly. Now, imagine motion across this sheet. The faster you travel, the more your path through time shifts to balance your path through space. This balancing act ensures that no matter how you move, the combined motion through space and time always respects the same ultimate speed. That speed is light, and it is built into the fabric itself. This is why the barrier is universal. It is not that rockets are weak or that humans are unprepared. It is that the geometry of reality does not permit any object with mass to move faster than light. If you try, the equations demand absurdities. Mass becomes infinite, time becomes frozen, energy becomes unbounded. It is the mathematical way. The universe refuses the attempt. Consider a beam of light itself. From our perspective, it moves at nearly 300,000 kilometers per second, a pace that would circle Earth 7 times in one heartbeat. But to the photon, if it could think, there would be no sense of journey at all. Emission and arrival would be the same instant, because for light, there is no passage of time. This is the edge condition of space-time, the extreme case that defines all else. And so, when we say the speed of light is the maximum, we are not talking about light alone. We are talking about every possible motion, every possible exchange of information. Whether it is a spaceship, a radio signal, or a ripple of gravity, all must obey the same boundary. It is not a restriction laid down from above. It is the natural result of how space-time is stitched. To travel near that limit is to see the rules revealed in their most dramatic form. Time slows for the traveler. Distances contract in the direction of motion. Energy requirements climb ever higher. These are not illusions but real consequences of the geometry of space-time. A twin who departs Earth at near light speed will return younger than their sibling who stayed behind. A particle accelerated in a collider will live longer than it would at rest. Relativity is not only theory, it is measured, tested, confirmed 1,000 times. The rules of the game are clear. You may move as fast as you like, but as you approach the edge, the cost grows unbearable. The very structure of space and time ensures that no signal can overtake light, because to do so would mean leaving the fabric itself. Faster than light is not travel, it is contradiction. It is a command that space-time cannot obey. The closer you examine this truth, the more profound it becomes. The universe is not arbitrary, it is not chaotic, It is bound together by logic deeper than any single particle or planet. The speed of light is the key to that logic, the constant that turns equations into laws and laws into reality. Without it, there would be no coherent story for the cosmos to tell. This is why the endlessly accelerating ship could never break the barrier. It was not a failure of technology, it was the unveiling of space-time's rules. The universe does not allow shortcuts in this game. The speed of light is the built-in ceiling, and every attempt to touch it only reaffirms its role as the fundamental thread. And as we press deeper into this understanding, we discover something even stranger. Approaching the speed of light does not only demand more energy, it makes the very fabric of physics turn hostile to the effort, as though the cosmos itself grows defensive when pushed too hard. Time bends, energy soars, causality trembles. It is as if the universe is guarding a secret, ensuring that no traveler may trespass beyond the limit without shattering the logic of existence. The story of relativity is not only about ships racing through the night or photons streaking across the cosmos. It is about how the universe itself defines what motion means. When Einstein revealed that space and time were not separate arenas but one continuous fabric, he gave us the first glimpse of why light speed is untouchable. He showed that every object, every signal, every force plays by the same rules, and those rules are written with light at their heart. Imagine space-time as a vast ocean, invisible yet real. Every particle, every planet, every star moves through this ocean, and their motion is not free to ignore its currents. Instead, their journeys are constrained by the geometry of this unseen sea. Just as a fish cannot leap beyond the surface of the water without leaving the realm in which it lives, no particle with mass can surpass the limit set by space-time itself. Light is the measure of that limit, the speed at which information flows across the cosmos. This is why the laws of physics are the same everywhere, no matter who is observing. A clock on Earth and a clock aboard a spaceship moving at half the speed of light will not agree on the passage of time, yet the laws that govern them are identical. They both exist within the same woven geometry. The differences arise not from a flaw in the universe, but from the way space-time balances itself to preserve its constant. The speed of light remains the same to both, no matter how they move. Consider two observers watching the same beam of light. One stands still on Earth, the other rides a spacecraft racing alongside it. Both measure the light, and both find it moving at the same speed. This is the strangeness of relativity. No matter how fast you travel, the light never changes its pace. Instead, time and distance shift around you to preserve the constancy of that beam. The universe bends itself to ensure the law is never broken. This constancy explains why no matter can outrun light. To do so would mean tearing apart the very fabric that keeps space and time coherent. It would mean redefining what distance means and what time means, collapsing the rules that give order to events. Faster than light travel is not simply forbidden because of energy demands. It is forbidden because it contradicts the foundation upon which reality rests. Even the most extreme phenomena in the cosmos confirm this truth. Neutrinos, those nearly massless particles that stream through every cubic centimeter of space, still obey the rule. They skim just below the speed of light, but never above it. High-energy cosmic rays, the most powerful particles known, strike Earth's atmosphere at velocities that push the barrier closer than any human machine could hope to achieve. Yet still, they fall short. Particle colliders accelerate protons until they circle the ring thousands of times each second, their energy greater than entire thunderstorms, yet still the wall remains. It is not only matter that is bound. Information itself cannot outrun the constant. No signal, no message, no cause can propagate faster. This is why the universe has an order that we can trust. This is why an event here cannot instantly affect something across the galaxy. The limitation gives causality its shape. It ensures that time has direction, that causes precede effects, that the universe does not collapse into paradox. As strange as these rules appear, they are also the reason we can understand the cosmos at all. Without the speed of light as a universal constant, the laws of physics would not be the same everywhere. Equations would shift from place to place, moment to moment. Experiments would lose their meaning. There would be no consistency, no reliability, no science. The universe would be chaos. So when we speak of the barrier, we are not speaking only of a challenge to engineers or dreamers. We are speaking of the very skeleton of reality. The speed of light is not fast simply because photons move quickly. It is fast because it is the maximum pace allowed by the rules that tie space and time together. To press against that barrier is to press against the foundation of existence. Yet there is another layer to this truth, one even more unsettling. For the closer you approach the barrier, the more the laws of physics themselves begin to twist into something hostile. Time no longer flows at the same rhythm. Space no longer stretches the same way. The universe itself begins to resist with effects that are as strange as they are absolute. The hostility begins subtly. At modest fractions of light speed, a traveler may not even notice. A ship moving at 1/10 of that limit still experiences time much like Earth, its crew aging at nearly the same rhythm as those left behind. But as the pace climbs, the differences begin to show. At half the speed of light, clocks aboard the ship tick slower than clocks at rest. At 3/4, the divergence becomes dramatic. A single year for the crew could correspond to nearly 2 years for their friends on Earth. The ship has become a time machine, not into the future by choice, but into the future by necessity. This slowing of time is not a trick of perception. It is as real as the ticking of a clock or the beating of a heart. Time itself stretches to ensure that the speed of light remains constant. It is the price of motion within the fabric of space-time. The closer one presses toward the barrier, the greater the price becomes. The ship may roar with power, yet the crew feels less and less of that effort as progress in speed. Instead, what they feel is time bending around them. Distances, too, join this distortion. The span between stars appears to contract along the direction of motion. A journey that would take centuries at rest seems compressed to decades or less for the travelers. This is not a mere illusion, but a reshaping of space-time geometry itself. The cosmos conspires so that the traveler's path is shortened in their frame of reference, while observers elsewhere still measure the longer distance. Both views are correct within relativity, both tied together by the unyielding constancy of light speed. Yet every one of these effects grows sharper as the barrier approaches. At 99% of light speed, time for the traveler slows to nearly 1/7 of normal. At 99.99, entire decades pass for outsiders, while only days pass aboard the ship. Push farther, and centuries unfold outside, while mere hours tick inside. The ship becomes cut loose from the familiar rhythm of the universe, its crew living in an isolated pocket where time is almost still. And then comes the energy wall. Each increment closer to light speed demands more fuel, more thrust, more sacrifice. The mathematics is cruelly precise. At the exact speed of light, the required energy is not merely great, it is infinite. Infinity cannot be reached by any process in the universe. It is the signature of impossibility, the final guardrail beyond which nothing with mass can pass. This is the hostility of physics made manifest. Time resists by slowing. Space resists by contracting. Energy resists by rising, without bound. The entire universe seems to turn against the attempt, not maliciously, but inevitably, as if defending its own order. The closer you draw to the barrier, the more you realize it is not a goal, but a horizon. You can approach it, but you cannot touch it. The lesson is clear. The speed of light is not simply a fast number. It is the keystone that holds space and time together. It is the maximum pace at which information can travel, the guardrail that keeps causality safe, the thread that ensures the universe does not unravel into paradox. It is not merely a law among many. It is the rule from which all others take shape. The crew of our imagined ship has discovered this truth not in equations on a chalkboard, but in the lived strangeness of their voyage. They set out to break the barrier, but what they found instead is why the barrier must never break. It is the foundation of all coherence, the law that gives reality its stability. As they gaze into the distorted tunnel of starlight ahead, they understand that their pursuit was not in vain. They have not failed. They have uncovered the deeper secret of the cosmos, that existence itself is woven into space-time, and space-time is stitched together by the constancy of light. The barrier they sought to defeat is in truth the reason they exist at all. And so, Chapter 2 closes not with frustration, but with clarity. The rules of the game have been revealed. Space-time is the fabric, light speed is the thread. Together, they form the tapestry of reality. But the story is not finished, for as we push closer to the barrier, the hostility grows, and with it, the realization that energy itself becomes the executioner of our ambitions. To see the barrier fully, we must step into the wall of infinite energy, where physics itself lays down its most uncompromising command. There is a point in the chase for light speed when the problem shifts from strange distortions of space and time into something more brutal, something that no ingenuity can outmaneuver. It is the wall of energy, a wall higher than any mountain, harder than any metal, unyielding to any dream. For the endlessly accelerating ship, this is where physics speaks in its clearest and most uncompromising voice. At first, the climb seems manageable. To double your speed from 10,000 kilometers per hour to 20,000 takes only twice the effort. To double again is harder, but not impossibly so. Rockets, after all, do it every day. The ship presses onward, its engines gulping fuel, its crew steady in their resolve. But as the pace rises, the cost grows faster than the reward. At half the speed of light, the ship's mass appears to outsiders to have climbed to nearly 1.5 times its normal value. At 3/4, the figure has doubled. At 90%, it has more than doubled again. Each atom of the ship now carries a burden far beyond its rest, dragging behind it the weight of motion itself. The engines must supply not only thrust but the power to bear this growing load. The closer the ship moves to the barrier, the more absurd the demands become. At 99%, the energy required is already more than any planet could provide. At 99.99, the requirement leaps beyond the output of all the stars in a galaxy combined. At 99.99999, the numbers have passed any conceivable resource. By the time you reach for that final 9, you are staring into infinity. To reach the speed of light requires not great power, not cosmic power, but infinite power. Infinity is not simply large, it is unreachable. It is the mathematical signature of impossibility. You cannot gather it, you cannot borrow it, you cannot create it. No civilization, no matter how advanced, could ever amass such energy. It is the end of ambition, a wall, not of stone or steel, but of principle. And this wall does not only block spaceships, it blocks particles too. In colliders on Earth, scientists accelerate protons until they whip around rings at nearly the speed of light. Each proton carries energy equal to a fastball thrown by a human arm, concentrated into something smaller than an atom. They are the most energetic particles we can create. Yet even with all our machines, all our ingenuity, the protons never cross the barrier. They skim against it, closer than any ship could dream, but they always fall short. The wall remains untouched. Out in the cosmos, nature does the same experiment on grander scales. Supernovae hurl particles with energies beyond anything human technology can imagine. Black holes fling jets across galaxies. Cosmic rays slam into Earth's atmosphere with forces that dwarf our colliders. Yet, even they do not succeed. They, too, are trapped below the limit. The wall holds against all challenges, whether human or cosmic. The cruelty of this wall lies in its demand. You can always add another decimal place, always push closer, always chase with another fraction of effort, but each step costs more than the last, rising not linearly but exponentially. It is like climbing a staircase where each step is taller than the one before, until the final step towers beyond the sky. The mathematics is merciless. No one will ever climb that last step. And yet, there is a strange beauty in this cruelty. For the wall is not an enemy, it is a guardian. It ensures that matter cannot become light, that particles cannot collapse into contradictions, that causality cannot shatter. It is not a denial of possibility. It is the condition that makes possibility real. Without the infinite energy wall, the universe itself would unravel. The crew of our imagined ship learns this truth in the hardest way. Their engines burn, their fuel dwindles, their hopes strain, but the wall stands firm. No matter how clever their designs, no matter how vast their resources, they will never break it. They may approach it for eternity, but it will always recede one step beyond their reach. And so they see what physicists have always known. The speed of light is not a target to surpass. It is the frame within which motion itself has meaning. It is the rule that shapes every journey, every orbit, every beam of radiation. The infinite energy wall is not a failure of technology. It is the expression of space-time itself. But if energy bars the path forward, it is not the only barrier. For even before the ship exhausts its fuel, another limit rises, one stranger and more profound. As the wall of energy looms, the wall of time begins to appear. And what it reveals is that speed is not only a matter of distance and momentum, but of the very flow of existence itself. The ship's struggle against the infinite energy wall is echoed all across the universe. Every particle, every star, every black hole, that attempts to hurl matter toward the ultimate velocity confronts the same impossible demand. It is not only human engines that fall short, it is nature itself, relentless and vast, yet equally bound. In laboratories on Earth, scientists accelerate particles to nearly the cosmic limit. Protons in colliders circle a ring at close to 300,000 kilometers per second. With each lap, more energy is poured into them, and with each lap, their effective mass swells. Detectors watch as their lifetimes stretch, their clocks ticking slower and slower compared to particles at rest. Yet always, without exception, the final wall looms. The last fraction of light speed demands infinite energy. The closer the proton draws, the harder the wall pushes back, as if space-time itself is shouting, "No further." Now lift your gaze to the heavens. Cosmic rays streak across the galaxy, born from cataclysmic explosions, from supernovae, from the furious jets of black holes. These particles carry energies millions of times greater than our most powerful colliders. They strike Earth's atmosphere like arrows of fire, producing cascades of secondary particles that rain down across the sky. They are nature's most violent challengers to the speed of light, and yet they too fail. No matter their origin, no matter their violence, they remain just beneath the barrier. The wall of infinity holds. Consider what this means. Every phenomenon we have ever observed, every force, every particle, is bound to this same ceiling. It is a law not of circumstance, but of principle. The wall is not a barrier built out of obstacles to be cleared away. It is the horizon of physics itself. To imagine surpassing it is to imagine tearing reality apart. Think again of our accelerating ship. Its engines roar louder, pouring unimaginable power into the void. But the closer it comes, the more of that power is stolen away into the swelling weight of motion, into the warping of time, into the distortions of space. The crew cannot see infinity, but they can feel its pull. It is a hunger that can never be satisfied, a demand that grows without end. To move at the speed of light would mean feeding an appetite that devours stars, galaxies, and the entire universe, and still comes back for more. Infinity does not negotiate. It is not a challenge to be solved with cleverness or patience. It is the statement that something is impossible, and the impossible is not cruelty, but necessity. If the wall did not exist, if matter could reach and pass the speed of light, then photons themselves would no longer define the structure of reality. Information could travel instantaneously. Causes could be outrun by effects. The universe would collapse into contradictions. The infinite energy wall is therefore more than a limit. It is a safeguard. It is the guarantee that light remains, the measure of space-time, that order is preserved, that the flow of time remains unbroken. Without it, galaxies would not cohere, stars would not shine as they do, and life would never have emerged. The wall we cannot cross is the same wall that makes our existence possible. Even black holes, the most extreme objects in nature, obey the command. They warp space-time until light itself cannot escape, yet still, the material falling toward them never outruns the constant. It spirals, it accelerates, it glows with fierce radiation as it approaches the event horizon, but the speed of light remains the unreachable ceiling. Even in the presence of gravity strong enough to trap light, the wall holds unbroken. And so, both human and cosmic ambition alike come to the same end. The speed of light is not conquered, it is obeyed, not out of weakness, but because the structure of space-time leaves no other option. The infinite energy wall is not an obstacle in the path of progress. It is the path itself, the shape of motion, the law of existence. For our ship, the lesson is bitter yet profound. They will never summon enough fuel to cross the barrier, never conjure the infinity required. Their dream of becoming light is denied. But in that denial lies a truth more beautiful than any victory. They have learned why the wall stands and why it must never fall. Yet as they stare into the endless dark, they realize that the story does not end with energy. For if they were to somehow ignore the demands of mass and power, another barrier waits. It is more subtle, more unsettling, and in many ways more absolute. It is the wall of time itself. And here, the consequences of approaching the speed of light grow stranger than imagination. The ship continues its futile climb, engines burning with fury, fuel dwindling into nothing, but the lesson is already written into the very stars above them. The infinite energy wall is not a boundary they might one day surpass with better machines or cleverer designs. It is a command written into space-time itself. Every push only tightens the grip of that command. Every attempt to add speed only feeds the demand for energy until the equation collapses into infinity. The crew begins to understand that they are not merely testing technology, they are testing the universe, and the universe has responded with finality. In their instruments, they see the math made real. At 99% of light speed, the ship is heavy, dragging a doubled mass behind it. At 99.99, the numbers swell again, their charts showing curves that steepen into walls. The graphs rise like cliffs with no summit, racing upward until they vanish into endlessness. It is not only a prediction, it is the shape of nature. Even in silence, the stars remind them of this truth. The photons that strike their eyes are not tired, not slowed. They travel effortlessly, at the ultimate limit, because they alone are born weightless. For them, there is no demand for infinite energy, because they do not carry the burden of mass. Matter can only watch them and follow from below, never joining them. The crew feels the sting of envy toward the light, but they also recognize its role as guardian. Without photons racing at that exact speed, space would not connect to time, and information would not weave the universe together. And as their ship grows slower in progress, though not in acceleration, they realize they are not alone in their struggle. Every galaxy, every quasar, every violent storm of particles has played this same game. The cosmos itself is a theater of challengers who have pressed against the barrier for billions of years, and none have broken it. From the tiniest proton in a collider to the most energetic cosmic ray streaking from a distant explosion, all share the same fate. They touch the wall, but never pass. The irony is stark. It is energy itself, the very source of motion, that becomes the jailer. What begins as fuel and propulsion transforms into weight and resistance, until the very thing that should drive them forward holds them back. It is as if the universe is taking their efforts and turning them into chains, ensuring they cannot break free. Yet those chains are not meant as cruelty. They are the bonds that keep reality intact. The ship, its crew, and even its dream become symbols of this truth. They are no longer voyagers, but witnesses to the architecture of reality. They see that the infinite energy wall is not an obstacle in their path. It is the foundation beneath their feet. To live in a universe without it would be to live in chaos, where messages outrun senders, where causes stumble behind effects, where time itself fractures. The wall is not a punishment, it is protection. And so the ship drifts on, never reaching the final goal, but carrying knowledge more profound than arrival. The speed of light is not merely the fastest velocity, it is the boundary of possibility, the horizon of meaning. Energy itself has revealed this, speaking in the language of infinity, declaring that the wall can never fall. But the story is not finished, for though energy builds the wall and mass obeys it, there is another frontier that bends even more strangely as the barrier is approached. It is the frontier of time itself. The crew has already seen hints of it in their slowed clocks and in the dilation of their lives. What awaits beyond the wall of energy is a deeper impossibility, one where time no longer flows in ways we can understand. The next revelation is not about the weight of matter or the hunger of infinity. It is about the breaking of time, and in that breaking lies the strangest consequence of all. The engines still thunder, but the crew of the imagined ship now faces something stranger than the resistance of mass or the hunger of energy. They face the quiet rebellion of time itself. For as their velocity climbs closer to the cosmic barrier, they discover that time does not belong to everyone equally. It bends and twists depending on motion, reshaping itself so that the universe can keep its promise to preserve the constancy of light. At first, the distortion is subtle. At 1/4 of light speed, their clocks still seem to match the rhythms of Earth. A second is a second. A heartbeat is a heartbeat. But hidden deep within the mathematics, the difference has already begun. The faster they go, the more their time diverges from the time of those watching at home. It is not a trick of perspective, not a quirk of measurement. It is as real as gravity, as undeniable as the pull of Earth itself. Imagine two twins. One remains on Earth, their life unfolding in the ordinary cadence of days and nights. The other boards the ship, racing into the stars at 9/10 of the speed of light. For every year the traveler experiences, more than 2 years pass for their sibling. If the voyage continues longer, the gap grows wider. When the traveler finally returns, they step off the ship decades younger than their twin. This is no science fiction invention. It is the twin paradox, a direct and measurable consequence of relativity. We have tested it not with humans, but with particles. Muons, unstable cousins of the electron, decay in millionths of a second when at rest. But when accelerated to near light speed, they live far longer, their clocks stretched by time dilation. The experiments match the equations with exquisite precision. Time really does slow for the fast. It is not imagination. It is the way the universe ensures that nothing ever outruns light. For the crew aboard the ship, the implications are staggering. They look at their chronometers and see hours, while Earth records days. They send messages that seem ordinary to them, but when they arrive at Earth, the timestamps reveal the distortion. They are travelers not only across space but across time itself, slipping into the future more quickly than those they left behind. The closer they press to the barrier, the more dramatic the effect becomes. At 99% of light speed, a year for the crew corresponds to 7 years on Earth. At 99.99, a day aboard matches centuries outside. And as the barrier looms, the flow of time for the travelers crawls nearly to a halt. The universe outside races forward while their lives freeze in a slow trickle of moments. If the ship could ever reach the exact speed of light, the flow of time for its crew would stop entirely. Their clocks would freeze, their heartbeats would suspend, their very existence would become timeless. For them, there would be no before and after, no past and future, no motion at all. They would not be travelers anymore. They would be trapped in an eternal instant. This is why photons, the messengers of light, experience no time. From their perspective, they are born and absorbed in the same moment, even if they cross billions of light years of space. They do not journey through the cosmos. They exist at its very edge, touching 2 points of reality at once, with no passage in between. Matter can never share this timelessness, because matter cannot abandon the flow of duration. The crew comes to understand the terrible implication. To chase the speed of light is not simply to battle energy demands. It is to battle the nature of time itself, and time does not yield. It slows and bends to keep the barrier intact, until at last it would vanish altogether. The ship would not become faster, it would become frozen, suspended, in an instant that never ends. And so the lesson deepens. The speed of light is not only about energy, not only about mass, it is about the very existence of time. The universe will not permit any traveler to break it, because to do so would unravel the meaning of before and after. To move faster than light would be to declare war on causality itself. The ship drifts on, and though its engines still burn, the crew begins to see the futility. They are not only blocked by infinity, they are blocked by the collapse of time. The closer they approach, the more their lives slip away from the rest of reality. They are voyagers into isolation, exiled into slower and slower time, until the final truth stands before them, like a mirror. To move at light speed is to stop moving altogether. But if time itself can be bent and stretched in this way, what happens if the barrier is broken? What happens if some clever loophole, some faster-than-light messenger, could exist? The answer is not triumph. The answer is paradox, where the future collapses into the past, and cause becomes tangled with effect. And that is where the story must go next, into the fragile chain of causality, and what happens to it when the speed of light is defied. The ship sails on into the abyss, its crew now captives of time's distortion. Their bodies feel normal, their thoughts move as they always have, but the gulf between their experience and the universe outside has widened into something extraordinary. They begin to understand that they are no longer only travelers. They are witnesses to time itself unraveling under the pressure of velocity. From the ship's frame of reference, everything seems ordinary. Their clocks tick steadily, meals are eaten at regular intervals, voices echo in normal cadence. Yet when they compare their measurements with signals from Earth, they see the fracture. Minutes for them have become hours for others. Hours for them have become days outside. The universe is racing forward while they linger behind, trapped in a slower current of duration. It is a strange isolation. The crew may speak to Earth, sending messages of reassurance or reports of their discoveries, but by the time their words arrive, years have passed. By the time the reply returns, decades may have unfolded. Families they left behind have aged, children have grown into adults, nations have risen and fallen, while they themselves have barely changed. They are alive, but separated by a chasm no bridge can cross. This isolation is not merely personal, it is cosmic. For any being pressing toward the speed of light, the same gulf emerges. The universe outside runs faster and faster, rushing ahead while the traveler drags behind. To the rest of existence, the ship, has nearly frozen. To the ship, the cosmos has become a torrent, racing past at impossible speed. Both views are correct, both equally real, because space-time demands it. The closer the ship draws to the barrier, the more merciless this distortion becomes. At 99% of light speed, every second they live is 7 seconds for Earth. At 99.99, one heartbeat for them may be a century for others. Push beyond, and the math climbs without end, stretching the difference until eternity itself pours through the gap. They are not only voyagers into space, they are voyagers into the future, dragged there by the weight of relativity. The thought experiment becomes tragic when carried to its extreme. If the ship could truly reach light speed, time aboard would stop altogether. The crew would become frozen, their last instant stretched into infinity. They would not see the stars slip by. They would not see their destination. They would not experience anything at all, because for them, there would be no later. There would only be a single, eternal now. This is why light itself is timeless. Photons do not experience journeys. They do not feel the millions of years it takes to cross the gulf between galaxies. From their perspective, emission and arrival are the same event. They are the pure expression of what it means to move at the ultimate limit. And for matter, this state is forbidden, because to share it would mean abandoning the flow of time. The crew realizes this truth with a mix of awe and despair. Their dream of becoming light was never about speed alone. It was about abandoning the very fabric of their existence. Without time, they are no longer travelers, no longer alive. They would be erased into the stillness of the barrier. And yet, even this strange law carries a beauty, for the bending of time is not only a punishment, it is also a gift. It is the reason that travel into the future is possible, not in fiction, but in reality. Astronauts who orbit Earth at high velocity already experience it in tiny doses. Their clocks tick ever so slightly slower than those on the ground. Particles in colliders live longer than their stillborn counterparts. This is not imagination. It is proof that time is malleable, that the universe allows journeys not only across distance but across eras. But the bending of time also warns of a deeper danger. If the speed of light is broken, if some signal or ship could surpass it, then the slowing of clocks would no longer protect the chain of events. Instead, the flow of cause and effect would collapse. Messages could arrive before they were sent. Travelers could return before they departed. Time itself would twist into paradox. The ship, its crew, and its futile quest have led us here, to the edge of comprehension. Energy has spoken with infinity. Time has spoken with silence. Both reveal the same truth: the barrier cannot fall. And if it did, reality itself would fracture. What awaits beyond this realization is not merely the slowing of clocks, but the breaking of causality itself. And in that breaking lies the greatest paradox of all. The ship presses on, though in truth it is no longer moving toward a destination in any familiar sense. Its voyage has become a descent into the strangeness of time. Outside its hull, the universe is racing, stars spinning through their own histories, galaxies colliding, civilizations rising and vanishing. Inside, the crew remains caught in a crawl of seconds, stretched thin, their lives unfolding, almost motionless compared to the torrent outside. The strange paradox is that they do not feel frozen. Their hearts beat in rhythm, their conversations flow, their clocks tick with reassuring steadiness. To them, nothing seems wrong. Yet they know from the signals exchanged with Earth that they are slipping deeper into isolation. Generations may live and die while they share a single meal. Worlds may turn to dust while they take only a single step. They have become castaways not only in space but in time itself. The mathematics reveals a terrible conclusion. At the precise speed of light, their own flow of time would collapse entirely. Their clocks would halt. Their thoughts would halt. Every process of their bodies would freeze into an eternal instant. The ship would not be destroyed in fire or impact, but erased into timelessness, its story ending not in catastrophe, but in silence. To exist at light speed is not to exist as matter, it is to be a photon, and photons do not live in time. This realization shatters the illusion of the journey. They are not chasing a frontier that might one day be reached. They are chasing an edge that will erase them if crossed. To become light is not to move faster, it is to abandon all motion, all change, all life. The barrier is absolute because it must be. Without it, time itself would lose its meaning. The crew stares into the star tunnel ahead, its brilliance compressed by their velocity, and they understand that they are peering not into space, but into the truth of time. The The closer they draw, the more the universe has to warp itself to keep their clocks ticking at all. The fact that they experience even a trickle of seconds is evidence of the barrier's mercy. Were they to reach the final threshold, even that mercy would vanish. Here lies the most profound revelation of their voyage. The barrier is not only a ceiling of speed, it is the safeguard of time. It ensures that no object of mass can ever live without a past or a future. It protects the chain of cause and effect, the flow that makes existence possible. Without it, reality would not have coherence. And yet, curiosity stirs a dangerous question. What if the wall were broken? What if some hypothetical particle, some phantom faster than light, could truly exist? The answer is not freedom. The answer is paradox. For such a particle could send a message into the past. It could reverse the order of cause and effect, making the consequence precede the action. It could fracture time into contradictions. The ship has reached its limit, not in distance, but in meaning. Their experiment has revealed the hidden covenant of the cosmos. The speed of light is the guardian of time. To reach it is to erase oneself from history. To surpass it is to invite paradox. And so Chapter 4 closes on a threshold stranger than any wall of energy or mass. The barrier is not only written in matter, but in time itself. And the next step is to peer into what happens if that chain is broken, if causality itself is bent or undone. The ship has shown us the wall of energy and the collapse of time. Now we must follow the thread further into the most fragile and mysterious territory of all, causality. For if the speed of light is the guardian of time, then faster than light travel is not merely a breach of motion, it is an assault on logic itself. To imagine signals outracing light is to imagine a universe where effects arrive before their causes, where events lose their sequence, where the story of reality fractures into paradox. Causality is the spine of existence. It is the chain that says a stone must be thrown before a window shatters, that a match must be struck before a flame appears, that a heartbeat must precede a pulse. Without it, nothing can be trusted. Science depends on it, memory depends on it, even thought itself depends on it. To break causality is to break the very possibility of understanding. Now imagine a device capable of sending a signal faster than light. A traveler aboard our ship could press a button and transmit a message that races ahead of photons. On Earth, the signal is received before the button is pressed. The traveler has spoken into the past. From one point of view, nothing is wrong. The signal traveled at its natural pace. But from another, the sequence has inverted. The effect has outrun the cause. The window has shattered before the stone was thrown. This is not simply a puzzle. It is a paradox that infects all of reality. If one can send a signal into the past, then one can warn oneself not to press the button. If the warning is obeyed, the button is never pressed. If it is never pressed, the signal is never sent. If the signal is never sent, the warning is never received. And if the warning is never received, the button is pressed. After all, the loop tightens until logic collapses. Reality cannot decide what has happened. Physicists have given names to these strange imaginings. They speak of tachyons, hypothetical particles that always move faster than light. They speak of closed time-like curves, paths through space-time that fold back upon themselves, allowing journeys into the past. They are not predictions of things that must exist, but warnings of what would happen if the barrier were ever broken. They are thought experiments that reveal why the wall is absolute. For our imagined crew, the danger becomes clear. If they could somehow break the barrier, they would not only face infinite energy or frozen time, they would face the collapse of causality itself. They might find themselves arriving at destinations before they departed, witnessing events before they occurred, sending messages that undo themselves. Their journey would no longer be a story with a beginning and an end. It would be a knot of contradictions. The universe does not tolerate such knots. This is why the barrier exists. It is not merely an arbitrary rule, but a defense against paradox. To allow faster than light travel would be to permit the unraveling of cause and effect, and with it the unraveling of meaning itself. The cosmos protects its coherence by making the barrier unbreakable. And yet, the imagination is restless. What if there are ways to skirt the edge without crossing it? What if causality could be twisted, but not destroyed, bent, but not shattered? Such questions lead us to the edge of physics, into realms where time loops, wormholes, and warps whisper of possibilities, but always with the same warning. To tamper with the chain of cause and effect is to court disaster. For now, our crew is safe, because their ship cannot cross the barrier. They can only imagine what lies beyond. But in that imagination they glimpse the most fragile truth of all. The universe is logical because light speed is constant. If the barrier falls, logic itself dissolves. The ship has shown us what it means to press against the barrier of time. Now we must follow the logic of that barrier to its most unsettling consequence. What happens when cause and effect themselves begin to slip? For causality is not just a convenient ordering of events. It is the very skeleton of reality. It is what makes the universe comprehensible. You know the match must ignite before the flame burns. You know the sun must rise before the day can unfold. Remove this order, and everything collapses into contradiction. Imagine again our ship, but this time outfitted with a transmitter capable of sending signals faster than light. The crew, eager to test their invention, presses the button. A message leaps ahead, racing back toward Earth, not bound by the sluggish pace of photons, but piercing through space-time with forbidden speed. To their astonishment, the signal is received on Earth before they press the button. From one perspective, all is well, the message traveled as expected, but from another, the sequence has inverted. The effect has arrived before the cause. This opens the door to paradoxes no universe can tolerate. Suppose the crew sends a warning to their earlier selves. Do not press the button. If the warning is obeyed, the button is never pressed. If it is never pressed, no message is sent. If no message is sent, no warning arrives. And if no warning arrives, the button is pressed after all. The loop locks itself into impossibility. Reality cannot resolve the contradiction. Physicists exploring such thought experiments gave names to these ghosts of mathematics. Tachyons, hypothetical particles that always move faster than light. Closed time-like curves, paths through space-time that bend back into the past. They were not predictions of things we expect to find, but warnings of what would happen if the wall of light speed were breached. They are mirrors, showing us the absurdity that lies beyond the barrier. Even the idea of sending information faster than light collapses into absurdity. Suppose two scientists in distant laboratories exchange signals that travel faster than light. From one point of view, the message leaves first and arrives second. From another, equally valid within relativity, the message arrives before it was sent. Both are true, depending on who is watching. This is not confusion, it is the breakdown of causality itself. The universe has ways of defending itself from such contradictions. Every attempt to find a mechanism for faster-than-light communication ends in walls of mathematics, or requirements for exotic materials that cannot exist. Every path toward outrunning causality collapses before it can begin. The cosmos enforces its logic, not with punishment, but with consistency. For our imagined crew, the lesson is clear. The speed of light is not just a barrier of energy or time, it is the safeguard of causality. It ensures that events follow one another in order, that consequences do not leap ahead of their causes, that history flows forward and not in circles. To break it would be to let paradox run free, and the universe does not permit paradox. And yet, at the edges of physics, whispers remain. What about wormholes? About warping space? About paths that skirt the rules rather than break them? Could there be loopholes where causality bends but does not shatter? These are questions for later. For now, the truth is stark. Faster than light is not simply forbidden, it is nonsensical. The ship drifts on, its transmitter silent, its crew aware that to use it would not be to speak into the void, but to speak into contradiction. And in that silence they understand why the barrier must stand, and why the universe guards it so jealously. The crew knows now that their ship can never surpass the speed of light, but imagination tempts them with shadows of what it would mean if they could. They picture particles born not below the barrier but beyond it, existing forever faster than light, forever slipping into realms that ordinary matter cannot touch. These phantoms have a name: tachyons. In equations, tachyons carry peculiar traits. They can never slow to light speed, just as ordinary particles can never accelerate to it. They live in a realm of perpetual excess, forever faster, never slower. Yet their existence would shatter the chain of causality. A tachyon, exchanged between two observers, could arrive before it was sent. A signal carried on such a messenger could write paradox into the bones of reality. And though mathematics allows us to play with their properties, no experiment has ever found them. They remain the ghosts of theory, reminders of why the barrier must hold. Closed time-like curves carry the paradox further. These are paths through warped space-time that loop back on themselves, allowing a traveler to return to their own past. They are permitted by the equations of relativity under extreme conditions around infinitely long rotating cylinders of mass, or within the twisted throats of wormholes. But these are not blueprints, they are warnings. For if such loops were real, then causality would dissolve into circles. A traveler might prevent their own departure. An event might cause itself. The narrative of the universe would collapse into contradiction. The cosmos seems to guard against such violations. Every attempt to make a closed time-like curve practical demands matter with negative energy, exotic substances that have never been observed and may never exist. Every calculation that seems to permit them also reveals instabilities that tear them apart before paradox can form. It is as if the universe enforces its logic by sabotaging any route that might undo it. For the crew of our thought experiment, the implications are sobering. They realize that their ship is not held back only by energy or by time, but by the deeper law of cause and effect. Their journey cannot rewrite its own beginning. Their messages cannot reach backward into their past. The cosmos insists that events must line up in sequence, that the shattering of glass must follow the fall of stone, not precede it. In this way, the speed of light is revealed not merely as a speed, but as the guardian of coherence. It is the line that ensures the universe tells a consistent story, one page after another, without loops or contradictions. To press against it is to press against paradox. To imagine passing, it is to imagine undoing the very meaning of reality. The ship sails on, humbled and silent. The crew has glimpsed what lies beyond the barrier, not as discovery, but as impossibility. They have learned that the cosmos does not merely discourage faster than light motion, it forbids it to preserve its own logic. And yet, the journey continues, because there is more to the story. For if the speed of light guards causality, then what of gravity, the other great shaper of reality? Gravity bends space, curves time, and even drags light itself into orbits and traps. How does this ancient force meet the law of the barrier? Can gravity, subtle and omnipresent, ever rival the constancy of light? The ship has taught us the limits of energy, time, and causality, but now our gaze must widen. Beyond the vessel, beyond the crew, beyond even the paradoxes of faster-than-light travel, there is a deeper duel playing out across the cosmos. It is the ancient rivalry between gravity and light. Two forces, one sculpting the curves of space-time, the other racing along those curves at the ultimate limit, locked in a contest that defines the structure of the universe itself. Light seems untouchable. It is the fastest messenger, the very definition of motion's ceiling, yet even light must bow to gravity. When starlight passes near a massive object, it bends, not because it is pulled like a stone, but because the fabric through which it moves has been curved. Einstein revealed this truth in the early 20th century, predicting that light grazing the sun would be deflected by its mass. In 1919, astronomers confirmed it during a solar eclipse, watching distant stars appear shifted from their positions. The universe had spoken. Gravity commands even light, not by slowing it, but by shaping the space it travels through. Imagine photons streaming across billions of kilometers, straight as arrows, then place a star in their path. The photons continue at their unchanging speed, but the stage beneath them has been warped. They follow the shortest possible paths, which in curved space-time are arcs, not lines. To us, the light seems bent. To the photon, it has done nothing unusual. It is still racing at the ultimate limit, obeying the only law it knows. This rivalry deepens near extreme masses. Around a neutron star or a black hole, light can be bent into circles. At a precise distance from a black hole, called the photon sphere, beams of light can orbit indefinitely, trapped in loops around the darkness. And if light passes too close, it cannot escape at all. The black hole's event horizon marks the place where the curves of space-time have become so steep that every path forward leads inward. Light does not slow there, nor falter. It simply finds that every possible future ends inside the shadow. For the ship, this is a sobering reminder. Even if they cannot break the barrier of light, they cannot ignore the force that shapes it. Gravity is everywhere, and everywhere it sets the stage for motion. Light itself obeys gravity, not because it is weak, but because gravity is not a force in the ordinary sense. It is the geometry of space-time itself, and all motion, no matter how fast, must follow that geometry. Yet there is something astonishing in this rivalry. Gravity can bend light, trap it, curve it into orbits, but it never outruns it. No gravitational influence, no matter how strong, moves faster than light. When stars collapse or black holes merge, the ripples of space-time gravitational waves race outward at the same ultimate speed as photons. Gravity and light share the limit together, two manifestations of the same underlying fabric. The crew of the ship peers outward and realizes that even the cosmos's mightiest structures obey the same barrier. They see galaxies where gravity binds billions of stars, where light weaves patterns through gravitational lenses, where the dance of mass and radiation creates beauty and order. Everywhere, the rivalry plays out. Light speeds forward, tracing the structure of reality, while gravity curves that structure beneath it. Neither wins, because both are bound by the same law. And in this balance lies the answer to a deeper question. The barrier is not meant to be broken, but it can be curved, twisted, shaped. Light always moves at its maximum speed, but space-time itself can be bent in ways that alter how journeys unfold. Gravity shows us this truth. It reveals that the barrier is not a prison wall, but a flexible boundary. And within that flexibility lies the hint of loopholes, warp drives, wormholes, and dreams of bending space-time instead of crossing it. For now, the crew knows only that gravity and light are locked in eternal rivalry, each shaping the other, each bound by the same speed. But their journey will soon turn toward the possibility that this rivalry holds a secret. Not a way to break the barrier, but perhaps a way to bend it. The rivalry between gravity and light reveals itself most clearly in the phenomenon of gravitational lensing. Imagine a galaxy far beyond our own, its light streaming toward Earth across billions of years. Between us and that galaxy lies a cluster of other galaxies, their combined mass so immense that it warps space-time itself. The light from the distant galaxy does not travel in straight lines as we once believed. It curves around the intervening cluster, splitting into arcs, rings, or even multiple images. Telescopes on Earth and in orbit capture these distorted forms, and we know we are not seeing tricks of glass or atmosphere. We are witnessing space-time bent by gravity, forcing light to follow its curves. What is most striking is that light never resists this command. It does not struggle, it does not falter. It continues at the same ultimate speed, racing through the warped fabric as faithfully as ever. To the photons, there is no distortion. They are still following the straightest possible path. It is only our perspective, rooted in the larger geometry of the cosmos, that reveals the bending. In this way, gravity demonstrates its mastery, not by breaking light's rule, but by redefining the stage upon which light moves. Black holes are the most dramatic expression of this rivalry. As a massive star collapses under its own gravity, its space-time curvature deepens until escape becomes impossible. At the event horizon, light itself is trapped, not because it slows, but because every possible direction forward leads inward. Photons released there cannot find a path that escapes to the wider universe. They still race at their maximum speed, but space-time itself has curved into a funnel with no way out. The result is a prison, not of walls, but of geometry. Even near the event horizon, light plays a delicate game. At the photon sphere, just outside the horizon, beams can orbit endlessly in perfect circles. Any small deviation inward pulls them into the black hole. Any small push outward allows them to escape. It is a razor's edge, a balance between the relentless velocity of light and the equally relentless curvature of space-time. Few places in the cosmos embody the rivalry so perfectly. And yet, despite all this power, gravity does not break the universal limit. When black holes collide, they generate gravitational waves, ripples in space-time itself. These waves surge outward, carrying information about the catastrophe. In 2015, detectors on Earth recorded them for the first time. The waves arrived at the same speed as light, matching it with uncanny precision. Gravity and light are rivals, but they are also bound together. Both are limited by the same cosmic constant, two sides of one law. For the crew of our thought experiment, these truths carry profound meaning. They realize that even the mightiest engines of the cosmos cannot outrun light. Black holes can trap it, galaxies can bend it, but nothing can exceed it. The barrier is not a contest of strength, it is the definition of reality. Gravity and light are not enemies but partners, weaving together the architecture of space-time. As they watch from their impossible ship, the crew sees the universe differently. They see light tracing the geometry of stars and galaxies, and gravity bending that geometry into spirals and arcs. They see how the two forces shape one another, how neither can exist without the other. And they understand that in this rivalry lies the key to every structure we know, the arcs of galaxies, the orbits of planets, the very shape of the cosmos. Yet gravity also whispers of possibilities. If space-time can be curved to trap light, perhaps it can be curved to release shortcuts. If the barrier cannot be broken, perhaps it can be bent, reshaped into tunnels or warps that allow travel without defiance of the ultimate law. The rivalry suggests not that the wall can fall, but that the wall may be flexible. The crew does not yet know what this means. They only feel the pull of curiosity, the same pull that has driven every physicist and dreamer to ask, if the barrier cannot be broken, can it be cheated? The rivalry between gravity and light reaches its most profound climax in the heart of black holes. Here, gravity bends space-time so severely that not even light can find a path outward. This is not because light has slowed, nor because its strength has waned, but because the geometry of reality itself has folded inward. Every line that once led outward now curves back toward the center. The photons still move at their unyielding pace, yet their futures are sealed. To an observer far away, this struggle appears strange and unsettling. As matter falls toward the event horizon, it seems to slow, never quite crossing. The light it emits is stretched into longer and longer wavelengths until it fades into invisibility. To those who watch, time itself appears to pause at the edge of the black hole. But to the falling matter, the plunge continues unimpeded, the crossing swift and inevitable. This is the language of relativity, where perspectives diverge, yet both remain true. In this theater, gravity seems to have triumphed. It has trapped light, the fastest thing in the universe, within a prison of its own making. Yet the victory is not total. Beyond the horizon, the universe remains untouched. Photons still streak across galaxies, gravitational waves still ripple through space, and both still obey the same limit. Gravity can curve space-time until light is caged, but it cannot command any messenger to exceed the constant speed. Even black holes themselves remind us of this truth. When two of them collide, the violence sends tremors through space-time, gravitational waves that reach across the cosmos. When they finally wash over detectors on Earth, they arrive neck and neck with light from distant explosions. The message is unmistakable. Gravity and light share the same pace. No matter how deep the well, no matter how violent the merger, both are bound to the same speed limit that anchors the universe. For the crew of our imagined ship, these revelations carry weight. They see that their struggle is not unique. Even the cosmos itself bows before the barrier. Stars may collapse, galaxies may twist, black holes may devour, but none can break the rule. Light always travels at its ultimate velocity. Gravity always shapes the stage, but never outruns the player. Together they define the boundaries of reality. The lesson is bittersweet. The barrier is unbreakable, yet it is not absolute in the way a wall of stone is absolute. It can be curved, bent, reshaped. Gravity proves that space-time is flexible, that paths can be twisted and folded. The speed of light is always constant, yet the distance that must be crossed can be altered. In this flexibility lies the seed of hope. Perhaps the barrier cannot be broken, but perhaps it can be sidestepped. And so, the rivalry between gravity and light does not end in victory for one or defeat for the other. It ends in balance, in the recognition that both are bound by the same law, yet both reveal the possibilities hidden in the fabric of space-time. For if gravity can trap light, perhaps gravity can also free travelers from the vastness of distance. If space-time can bend, perhaps it can bend in ways that grant shortcuts. The crew gazes into the black horizon of a distant hole and wonders, if light can be trapped there, can ships be carried elsewhere? If space-time can warp to form prisons, can it warp to form tunnels? The barrier remains unbroken, but a new question rises. What if, instead of breaking the law, we learn to bend it? The story now turns to these possibilities, the dreams of warp drives and wormholes, the whispered loopholes that tempt us with hope. They do not defy the speed of light, but they hint at paths that may twist around it. The crew has learned that the barrier of light speed cannot be broken. Energy rises into infinity, time collapses into silence, and causality unravels into paradox. Even gravity, master of stars and black holes, cannot outrun the constant. And yet, there is a whisper at the edge of physics, a glimmer of possibility that suggests perhaps the barrier need not be broken to be bypassed. If space-time itself can be curved, might it be reshaped into a shortcut? Might the path, not the traveler, be altered? This idea is not new. Human imagination has long been haunted by dreams of folding the universe, of stepping across gulfs in an instant, not by moving faster than light, but by letting light's own rules carry us through new geometries. In the language of physics, these dreams take shape as warp drives and wormholes. The warp drive was proposed in the late 20th century by Miguel Alcubierre, a physicist who dared to imagine what relativity itself might allow. Instead of forcing a ship to accelerate toward light speed, his idea was to bend space-time around it. A bubble of space would contract in front and expand behind, carrying the ship as though on a conveyor. Within the bubble, the ship would drift gently, never moving faster than light relative to its local space-time. Yet to an outside observer, the bubble could glide across distances at apparent superluminal speeds. The barrier would remain unbroken, yet the journey would be shortened. Wormholes are another such dream, tunnels through space-time that connect distant regions. Einstein himself, together with Nathan Rosen, described such bridges in the early 20th century. Imagine folding a sheet of paper so that two distant points touch, then piercing a hole between them. A traveler who steps through would cross vast cosmic distances in an instant, not by exceeding light speed, but by leaping through curved geometry. The laws remain intact, yet the effect is a shortcut through the cosmos. For the crew of our ship, these concepts shimmer like beacons of hope. They suggest that perhaps the endless gulf between stars is not absolute. Perhaps space-time, so rigid when confronted directly, is pliable when approached with creativity. Perhaps the dream of interstellar travel does not end with impossibility, but with reimagining the very medium of motion. Yet the whispers come with shadows, for both warp bubbles and wormholes demand exotic conditions. Alcubierre's drive requires negative energy density, a substance unlike anything known, something that would pull instead of push, repel instead of attract. Wormholes, too, require exotic matter to hold their throats open, else they collapse before anything can pass through. These are not resources hidden in the universe, waiting to be harvested. They are conditions that may never exist at all. The crew feels the weight of this. They realize that even the loopholes may be illusions, promises that vanish when tested, and yet, the mathematics does not forbid them outright. They remain perched between the possible and the impossible, tantalizing hints that perhaps the universe has corners still unexplored. So the story does not end. The ship may never accelerate to light speed, but perhaps it can ride the bending of space-time itself. Perhaps the rivalry of gravity and light is not only a contest, but a key. For if gravity can trap light, then perhaps with the right tools, gravity can also free travelers from the tyranny of distance. The crew imagines their ship cocooned in a warp bubble, stars sliding past in blurs as space-time itself carries them forward. They imagine plunging into a wormhole, emerging at another corner of the galaxy in the blink of an eye. They know the cost may be beyond imagination, the risks beyond survival, but they also know this: the barrier is absolute, but the fabric it guards may still be woven in unexpected ways. And so the dream of faster-than-light travel does not die, it transforms. It becomes not a dream of breaking the barrier, but of learning to bend it, to cheat without disobedience, to move not faster than light, but differently than light. The Alcubierre concept is one of the strangest gifts of relativity. It does not promise a ship that outruns light. Instead, it imagines a ship that never moves at all. Inside its bubble of warped space-time, the vessel drifts, as if anchored in calm waters. It is the bubble itself that surges forward, contracting the fabric ahead and stretching the fabric behind. To outside observers, the bubble glides faster than any photon. To the passengers inside, no acceleration is felt, no crushing force endured. They are simply carried, as a leaf might ride a current. At first, this seems like a miracle. Relativity itself appears to offer a loophole, a way to travel between stars, without ever breaking the ultimate law. But the fine print is merciless. To bend space-time in this way requires not ordinary matter, not fuel or fire, but something wholly alien: negative energy. Unlike all familiar substances, which add to gravity by pulling inward, negative energy would push outward, repelling space-time, sustaining the expansion behind the bubble and the contraction ahead. Does such a thing exist? Physics has caught glimpses, faint hints, in the quantum realm. The Casimir effect, where two plates placed close together in a vacuum experience a subtle pull, can be described in terms of negative energy densities between them. Hawking radiation, the faint whisper of evaporation from black holes, involves similar mathematics, but these effects are delicate, microscopic, fleeting. To build a warp bubble large enough to carry a ship would demand negative energy on a scale far beyond anything observed. The equations do not forbid it outright, but the practical path remains buried in impossibility. Wormholes carry a similar promise and a similar curse. The idea that two distant regions of space-time could be connected by a tunnel is elegant and strangely natural in Einstein's equations. But the throat of such a tunnel is unstable. Without exotic matter to hold it open, it collapses in an instant, sealing itself before anything can pass through. With exotic matter, in theory, it might be traversable. Without it, it is a mirage. The crew of the imagined ship contemplates these loopholes with both wonder and dread. They see the possibility of journeys across the galaxy in a heartbeat, the possibility of reaching worlds not in centuries, but in moments. They also see the cost. The materials do not exist. The forces required may never be controlled. Even if a wormhole could be opened, the risks of collapse, radiation, or paradox could erase any traveler who dares to step inside. And yet, the vision is irresistible. It paints a cosmos where distance is not an absolute prison, where the gulfs between stars are not eternal divides. It suggests that the universe may be stranger, more pliable, more generous than it first appears. Even if warp drives and wormholes remain forever out of reach, their presence in the mathematics is a kind of promise. Relativity is not only a law of limits, it is also a language of possibilities. The crew imagines their ship slipping through a wormhole mouth, stars vanishing in a tunnel of warped geometry, only to reappear in a new sky across the galaxy. They imagine their bubble sliding forward on tides of negative energy, carrying them to worlds uncounted. They know the universe has not yet granted these dreams, but they also know that the cosmos often reveals what was once impossible to be merely undiscovered. And so they press on, not by breaking the barrier, but by imagining ways to bend it. The dream of faster-than-light travel remains alive, fragile but luminous, resting not in defiance of physics, but in its most daring interpretations. The loopholes that shimmer with promise also cast long shadows. For while warp bubbles and wormholes sound like invitations to cheat the cosmic barrier, both are built upon foundations so fragile they may crumble before any traveler sets foot within them. The Alcubierre drive, that elegant bubble of warped spacetime, demands negative energy in amounts far beyond any known source. Even if such energy could be summoned, the bubble brings dangers of its own. Its front edge, where spacetime contracts, could sweep up particles and radiation, compressing them into a lethal shockwave that bursts outward when the bubble stops. The passengers within might feel no acceleration, but the universe around them would be scarred by their passage, and the bubble itself, once formed, may not be steerable. It may surge uncontrollably, carrying its occupants to unknown fates. Wormholes carry a similar menace. Their mouths may promise instant travel across the cosmos, but their throats are unstable, collapsing faster than light itself could pass through. To hold them open requires exotic matter, not only in vast quantities, but arranged with impossible precision. Even if such a throat could be stabilized, the wormhole would act as both bridge and trap. Stray too near its edge, and gravity would seize you, dragging you into collapse. Step through without care, and you might emerge in a region where tides of space-time tear you apart. For the crew of the imagined ship, these dangers are sobering. They see that while loopholes tempt, they are not gifts freely offered. They are riddles with costs that may outweigh their promises. Even if humanity someday gathers the knowledge to bend space-time this way, the risks of catastrophe will remain immense. Perhaps these loopholes are not truly paths for travelers, but mirrors showing us the elasticity of the cosmos, hints that reality is stranger than we can yet tame. Still, the whispers of possibility cannot be silenced. Even if warp bubbles and wormholes remain out of reach, they reveal that relativity is not a cage of denial. It is a framework vast enough to hold not only limits but wonders. The same mathematics that declares the speed of light unbreakable also hints that space-time can be twisted into forms that defy common sense. Within those hints lies inspiration, if not yet transportation. And so the crew's journey continues, their dreams reshaped. They no longer imagine themselves sprinting past light, nor shattering the barrier with brute force. Instead, they imagine bending the rules at their edges, exploring the strange geometries where distance may not mean what it seems, where paths may fold and connect in ways hidden from ordinary sight. The barrier of light speed still stands, unbroken and absolute, but the possibility of loopholes shows that the universe is not a rigid prison. It is a flexible fabric, one that can be shaped into arcs, tunnels, and bubbles. Whether these shapes can ever be harnessed is unknown. But they reveal something profound. The cosmos is not only a place of limits, it is also a place of imagination. And yet, even as these dreams flicker, another question rises, darker and more unsettling. What if the barrier itself did not exist at all? What if the speed of light were not the ultimate limit? Would the universe open into endless possibility or collapse into chaos? The ship has revealed to us the guardianship of energy, the collapse of time, the fragility of causality, and even the strange loopholes whispered by warped space-time. Each lesson has pointed to the same truth. The speed of light is more than a number, more than a barrier. It is the framework that holds reality together. But now, let us step into a more dangerous imagination. Let us peel away the wall entirely and ask, what if the speed of light were not the limit? At first, the vision seems intoxicating. Imagine ships that cross galaxies in moments, messages that leap instantly between worlds, civilizations linked across the cosmos as easily as neighbors across a street. Distance would dissolve, and the universe would feel intimate, every star a reachable neighbor. Humanity's greatest dream would be fulfilled. But beneath this shining vision lies a darkness. For if the barrier falls, the laws that depend upon it begin to collapse, and with them, the order of the cosmos. Consider causality. If signals can travel faster than light, then effects can precede their causes. A commander could send an order that arrives before it was spoken. A scientist could publish a result before the experiment was performed. The universe would tangle itself in contradictions. What once was a clear sequence of cause and effect would dissolve into chaos. Without causality, the chain of events that makes reality comprehensible would be broken. Now consider stability. The galaxies we see today are bound together by the balance of gravity and the finite speed at which information can travel. If light speed were not the limit, then gravitational influence could spread instantly. Every star's tug would be felt by every other star without delay. The delicate structures of galaxies would shatter under this immediacy. Orbits would unravel. The great spirals of the cosmos would collapse into chaos. The same would be true for radiation. Stars shine because photons carry energy outward, escaping at a constant speed. If light could be surpassed, then the very nature of radiation would falter. Stars might burn themselves out in instants, their lifespans reduced from billions of years to mere moments. The light that nourishes life on planets would vanish as quickly as it appeared. Without the barrier, the sky itself might never have lit up. Even deeper, time itself would lose its shape. Relativity binds space and time into one fabric, with the speed of light as its thread. Remove the limit, and the fabric unravels. There would no longer be agreement on what is simultaneous, on what is before and after. Observers would live in universes where histories contradicted one another, where events did not align. Reality would fragment into a chaos of perspectives with no common ground. For the crew of our ship, this thought experiment becomes more frightening than inspiring. They had once dreamed of breaking the barrier to achieve freedom. Now they see that without the barrier, there may be no freedom at all. A universe without the speed of light as its constant is not a universe of possibility. It is a universe of collapse. The limit, then, is not a cage, but a foundation. It keeps stars shining, galaxies whole, and time coherent. It prevents paradox, ensures causality, and preserves order. The speed of light is not simply an obstacle that denies ambition. It is the scaffolding upon which ambition can exist. And so, imagining its absence becomes a lesson in gratitude. The wall that frustrates explorers is the same wall that makes exploration meaningful. The cosmos may feel vast and unreachable, but it is precisely the barrier that ensures the journey is possible at all. For the crew staring into the endless dark, the realization settles. The speed of light is not an enemy. It is the architecture of reality. And without it, the universe would not be wondrous, it would be impossible. The crew allows the vision to unfold further, and with each layer the dream of a limitless universe grows darker. Without the speed of light as the ultimate boundary, the cosmos loses its rhythm. The careful pacing of events, the long lifespans of stars, the orderly dance of galaxies, all of it begins to unravel. Start with the stars themselves. They shine because photons born in their cores take thousands or even millions of years to fight their way to the surface. In that long journey, the star's life is paced. Energy leaks outward slowly enough to balance gravity's pull. If light could travel infinitely fast, the delicate equilibrium would vanish. Energy would escape instantly, and the star would burn itself out almost as soon as it was born. Suns would flicker like sparks, instead of enduring as beacons for billions of years. Worlds would never have the chance to form, let alone sustain life. Now turn to galaxies. Their shapes are sculpted by gravity acting at the finite speed of light. Stars tug on one another with delays, and those delays allow stable structures to form. Spiral arms wind gracefully, clusters hold together, galaxies orbit one another in slow and majestic dances. But if gravity acted instantly, every star would feel the pull of every other star without pause. Stability would collapse. Orbits would distort and break, spiral arms would dissolve, and galaxies would collapse into chaos. The grand architecture of the cosmos would never take shape. The chaos would not stop at the cosmic scale. On planets, radiation and causality govern chemistry, biology, and thought. Nerve impulses travel slower than light, but depend upon the consistent order of cause and effect. If signals could arrive before they were sent, the logic of biology itself would unravel. A muscle might twitch before the brain commanded it. A seed might sprout before water touched it. Life as we know it depends upon sequences that unfold in time, and time itself depends on the barrier of light speed. Remove it, and living systems collapse into incoherence. The crew pictures their ship in such a universe. They see stars exploding in instants, galaxies twisting into knots, messages arriving before they are spoken, histories contradicting one another with every glance. They see a cosmos stripped not of limits, but of meaning. To them, it is no longer a place of wonder, but a place of nightmare. The very order that makes discovery possible is gone. And so they realize that the limit is not merely protection against impossibility, it is the foundation of beauty. The galaxies we admire, the suns that shine upon us, the flow of seconds that carry us forward, all are made possible because there is something they cannot exceed. The barrier does not diminish the universe, it creates it. The irony is clear. The dream of faster-than-light motion has always been framed as liberation, as escape from chains. But the absence of the chains would not be freedom, it would be collapse. To remove the wall would not open the cosmos, it would destroy it. The crew, who once longed to smash through the barrier, now understand that the wall is not there to hold them back, it is there to hold everything together. Their journey becomes not an attempt to defy the limit, but an exploration of why the limit is the reason they exist at all. And as they peer into the dark, they know the next question must be asked. Could the limit ever change? Could the universe have been born with a different constant? Or might it someday evolve into one? The dream of breaking the barrier may be impossible, but the dream of a changing barrier lingers. And with it comes the temptation to wonder if the speed of light itself has always been what it is today. The vision of a universe without the barrier stretches onward, and the more the crew imagines it, the clearer its fragility becomes. Without the constancy of light speed, the cosmos itself would never have formed as it did. The early universe, born from fire and expansion, depended upon that limit to pace its unfolding. If signals and particles could have outrun the barrier, density fluctuations would have spread chaotically. Galaxies might never have condensed from the primordial plasma. The very seeds of structure would have been scattered before they could take root. Even the cosmic microwave background, the faint afterglow of creation, depends upon the barrier. Its uniformity and its tiny ripples are written by the rules of light speed. Strip away that rule, and the radiation would be scrambled, smeared into patterns with no order, no trace of a coherent origin. Astronomers would not look up and see the fingerprint of the beginning, they would see only noise. The collapse reaches even deeper into meaning. Mathematics itself depends on causality, on sequences that follow one another in order. In a universe where faster-than-light signals were possible, proofs and logic would break down, because information could leap backward in time and unravel the assumptions on which reasoning is built. Science itself would be impossible, for experiments could not be trusted to have causes that precede their results. A cosmos without the barrier is not only a cosmos without stability, but a cosmos without knowledge. The crew lingers in this thought experiment, and they feel the weight of it. Their ship, their journey, their very existence are only possible because the wall stands. To imagine life in a universe without it is to imagine not an open frontier, but a void, without order, without science, without story. And so they see the paradox of the dream. To desire the breaking of the barrier is natural. It speaks to the hunger for exploration, for freedom from constraint. But to succeed in such a dream would be to erase the very ground upon which dreaming is possible. The limit frustrates, but it also sustains. It blocks ambition, but it also grants meaning. In this realization lies a strange peace. The crew no longer sees the speed of light as an obstacle in their way. They see it as a silent guardian, one that has shaped galaxies, sculpted stars, and allowed their ship to exist in the first place. The wall is not the end of their journey. It is the reason the journey can begin. Yet questions linger. If the limit is so absolute, could it ever shift? Was it always what it is now? Or could it have been different in the early universe? Could it change in ways we do not yet understand? The barrier may be unbreakable, but is it immutable? These questions lead the crew to their next frontier, into theories of varying light speed, into the inflation of the early cosmos, into the whispering foam of the quantum vacuum. The story does not end with the acceptance of the barrier. It continues with the mystery of whether the barrier itself is eternal. The crew has come to see the speed of light not as an enemy, but as the architecture of reality itself. They have accepted that to break the barrier would unravel energy, time, and causality, collapsing the beauty of the cosmos into contradiction. Yet a question remains, subtle and unsettling. If the barrier cannot be broken, can it ever change? Is the speed of light truly eternal? Or is it possible that in other epochs of the universe, or under other conditions, its value could have been different? This is no idle curiosity, for the cosmos has already revealed that constants we take as fixed may shift in the furnace of creation. In the first fractions of a second after the Big Bang, the universe expanded at an astonishing pace, a phase known as inflation. During this epoch, space itself stretched faster than light could cross it. This did not violate relativity, because no particle or signal outran light within its local frame. Instead, it was space-time itself that expanded, carrying regions apart more quickly than light could bridge. In this way, galaxies that are now billions of light-years away were once close enough to exchange light before inflation pulled them apart beyond reach. To some physicists, inflation raises a daring possibility. If space-time could stretch at superluminal rates, could the speed of light itself have been different in those ancient times? Might the cosmos we see today bear traces of a varying constant, frozen into its structure, like fossils in stone? The idea of a variable speed of light, or VSL, is controversial but fascinating. Some theories propose that in the early universe, light may have traveled faster, smoothing out irregularities and explaining the uncanny uniformity of the cosmic microwave background. Others suggest that shifts in fundamental constants could resolve puzzles about the strength of forces or the fine balance that allows stars and galaxies to form. If light speed was greater in the past, then the horizon problem, the question of why distant regions of the universe look so similar despite never exchanging signals, could be answered without inflation. But such ideas come at a cost. If the speed of light can vary, then so too might the structure of space-time. Relativity itself rests on the constancy of light. To change it is to rewrite the equations of reality. Many physicists resist the notion, arguing that the beauty and consistency of relativity are too deeply woven into observation to permit such shifts. The cosmos we see, with its elegant structures and precise order, seems to demand an unchanging barrier. The crew of the imagined ship ponders this possibility with awe. If the speed of light was different in the early universe, then the barrier they face is not eternal, but historical. It is not only a law, but a chapter in the story of reality. The value they measure now, 300,000 kilometers per second, is not sacred, but contingent, a reflection of the conditions of this cosmic era. And yet, evidence remains elusive. Every experiment, every measurement of distant galaxies, every observation of radiation across the sky points to constancy. The speed of light appears the same today as it was billions of years ago, when the oldest photons we can detect first began their journey. If it did vary, it did so before those photons were released, in an epoch hidden from direct view. Still, the question remains alive, because physics itself is not complete. Quantum mechanics and relativity remain estranged, their union unresolved. In the attempt to bring them together, in the search for a theory of everything, there are hints that constants may not be as fixed as they seem. At the smallest scales, in the foam of space-time itself, there may be fluctuations that ripple through even the sacred speed of light. For the crew, this possibility is both exhilarating and terrifying. To live in a cosmos where the barrier can shift is to live in a cosmos less stable, less eternal. Yet it also suggests that the story of the speed of light is not finished. Perhaps it had a different value in the beginning. perhaps it will have a different value in the far future. Perhaps the constant we treat as absolute is only absolute for now. The barrier has been revealed not only as unbreakable, but as mysterious. To ask if it can change is to ask whether reality itself is still unfolding, whether the laws of nature are themselves part of a greater evolution. And so the journey continues, not into speed, not into distance, but into the hidden question of whether the barrier is eternal. The crew turns their gaze backward through time, toward the earliest moments of the universe. They know that what we call constants, those unyielding numbers that govern nature, were forged in the crucible of the Big Bang. Could it be that in that primordial chaos, the speed of light was not what it is today? Some cosmologists have dared to suggest so. Variable speed of light theories, or VSL, emerged as alternatives to the inflationary model. They propose that in the first instance, after creation, light traveled faster than it does now. If this were true, it would help explain one of cosmology's great puzzles, why the universe looks so uniform across vast distances. Opposite sides of the cosmic microwave background, the ancient afterglow of creation appear almost identical, even though by the rules of today's light speed, they should never have been in contact. Inflation solves this by stretching space itself at superluminal rates. VSL offers another path, suggesting light itself once crossed those gulfs more quickly, sowing the cosmos into the smooth expanse we see. To the crew, this idea feels like peering into an alternate lawbook of reality. Imagine a young universe where photons did not crawl outward at 300,000 kilometers per second, but raced across distances far swifter. In such a universe, information could spread more freely, matter could clump into galaxies more evenly, and the seeds of structure would be written with a broader brush. The cosmos we inhabit might bear the fingerprints of this faster epoch, traces hidden in the microwave background and the distribution of galaxies. But the beauty of the hypothesis is matched by its difficulty. Relativity is built upon the constancy of light. To allow its speed to vary is to tug at the threads of the entire tapestry. The equations of physics are not independent pieces but an interwoven whole. Alter light speed, and you alter space, time, energy, and causality itself. The symmetry and elegance of relativity are not easily surrendered. For this reason, many physicists see VSL not as a serious contender, but as a provocative thought experiment, a way of testing the limits of our assumptions. Still, the question lingers, because physics is not yet unified. At the smallest scales, where quantum mechanics rules, space-time is thought to foam and fluctuate. In that restless churning, where virtual particles appear and vanish, and where geometry itself is uncertain, perhaps the speed of light is not perfectly constant, but dances around its average. If so, then what we measure as an unyielding value may be an emergent property, a stability that rises only when countless fluctuations are averaged together. Beneath that stability, there may lie a restless, shifting ocean. For the crew of our thought experiment, the vision is staggering. They imagine a universe where light speed is not eternal but evolving, where, in the earliest moments, photons blazed faster than they do now, and where at the Planck scale of space-time, fluctuations still ripple through the barrier. It suggests a cosmos where the laws we know are not fixed for all time, but part of a deeper story, a narrative of change written across epochs. And yet, evidence is stubborn. Every observation across billions of years shows no drift, no wobble, no deviation from the constant. The photons of the cosmic microwave background, traveling since the universe was young, arrive at Earth with perfect consistency. The light of distant quasars, passing through clouds of gas and galaxies across unimaginable time, behaves as faithfully as light produced in laboratories today. If the speed of light has changed, it has done so in ways too subtle for us yet to see. The crew sits in silence, contemplating this duality. On one hand, constancy as solid as the stars themselves, confirmed by every experiment. On the other, speculation that hints at hidden depths, at laws that may not be eternal after all. They realize that even if the speed of light has never varied, the very possibility invites humility. What we call constants may only be the surface of a deeper truth, and the cosmos may still hold surprises that rewrite what we believe unchangeable. The barrier remains, unbroken and unbending, but the question of its permanence has led them into a greater mystery. Are the laws of physics themselves laws, or are they chapters, evolving across time? The ship drifts onward, carrying the crew not through space but through thought, deeper into the mystery of the constant they cannot outrun. If the speed of light could ever change, how would we know? Could we measure it across the gulfs of time, or would its variations be hidden too deeply within the fabric of reality? Physicists have sought the answer in the sky itself. Every photon that reaches us from a distant galaxy is a messenger from the past. By examining the light of quasars and the absorption patterns of ancient gas clouds, scientists can test whether fundamental constants have shifted over billions of years. If the speed of light had been different, those spectral lines would be altered, slightly displaced from the values we know today. So far, the results reveal remarkable consistency. Across distances measured in billions of light years, the patterns match, as if the universe has been singing the same note since its birth. But the search continues, for the tools grow sharper with every generation. Telescopes now probe deeper, detectors grow more precise, and even gravitational waves are becoming instruments of measurement. These cosmic messengers, rippling across space-time, travel alongside light from catastrophic events. If the speed of light were not constant, such arrivals would drift apart. Yet again and again, the messengers arrive in unison, light and gravity bound together at the same unchanging pace. For the crew, the message is clear. The barrier has held, not only here and now, but across the ages. If it ever shifted, it did so in the unreachable dawn, before the cosmic microwave background froze its imprint into the sky. If it shifts still, it does so in realms too fine for our instruments, perhaps in the quantum foam, where space-time itself is uncertain. But in every way that matters for stars, galaxies, and life, the barrier has proven steadfast. This realization brings a quiet awe. The crew understands now that the constancy of light speed is not only a law, but a gift. It is why galaxies remain coherent, why radiation carries energy predictably, why experiments yield the same results today as yesterday. Without such constancy, science itself would be impossible. The universe would not be a place that could be studied or even comprehended. It would be a chaos of shifting rules. And yet, the possibility that the barrier could be part of a deeper story is equally humbling. If constants can evolve, then we are not standing on the bedrock of reality, but on a surface carved by history, resting atop layers we do not yet see. Perhaps the constancy we measure is only local, temporary, an agreement forged by the universe to sustain order in this epoch. If so, then the speed of light is not merely a number, but a moment in time, a phase of reality's unfolding. The crew lets this truth settle. Whether eternal or evolving, the barrier has shaped everything they know. Its value is woven into the stars, into the chemistry of life, into the beating of their own hearts. It is the measure of distance and the rhythm of time. To question it is to question the architecture of existence itself. And so their journey prepares to reach its final chapter. They have explored acceleration, energy, time, causality, gravity, loopholes, and the nightmare of a universe without the limit. They have even wondered whether the limit itself could change. What remains now is not speculation or paradox, but reflection. To step back and see the beauty of the barrier, to recognize that the speed of light is not a prison wall, but the foundation of wonder. The story of the barrier is not the story of limitation, but of creation. It is the reason the universe holds together, the reason science is possible, the reason the night sky burns with light that has traveled across billions of years to meet their eyes. And in that beauty lies the final lesson of their journey. The ship has crossed not distances, but truths. The crew has pressed against the barrier of light, learned why it cannot be broken, seen how energy, time, and causality rise up in defense of the constant. They have traced the rivalry of gravity and light, wandered into the dreams of warp bubbles and wormholes, and even dared to imagine universes without the limit or with the limit changed. At last they arrive at a new horizon, not one of conquest, but of understanding. It is here that they see the speed of light, not as a chain, but as a thread that weaves the cosmos together. For all their longing to surpass it, they realize that the barrier is the very reason they can long at all. Without it, stars would not shine in steady fire. Without it, galaxies would not dance in spirals. Without it, the story of time itself would dissolve into contradiction. The constant that frustrates explorers is the same constant that grants them a universe worth exploring. The crew reflects on the lessons of their journey. When they tried to accelerate endlessly, they found the wall of infinite energy. When they examined time, they discovered its collapse into stillness at the barrier. When they dared to imagine faster than light signals, they saw paradox and causality collapse. When they followed light into the grip of gravity, they saw how space-time bends, but never allows the limit to be outrun. Every path returned to the same truth. The barrier is absolute, and in that absoluteness lies coherence. This truth reshapes their vision of exploration. Perhaps humanity will never leap across the stars in moments. Perhaps ships will never sprint beyond the constant, but the cosmos remains vast and wondrous, even at sublight speeds. Generations may carry journeys across gulfs, machines may drift for eons, messages may take years to cross. Far from diminishing the grandeur of space, this pacing adds to it. Each crossing is hard-won, each signal hard-earned, each discovery an achievement against the measure of distance and time. The barrier makes every voyage into a story, and yet the dream does not vanish. Even within the constancy of the limit, creativity thrives. Warp drives and wormholes remain in the equations, whispering of strange geometries yet to be understood. The barrier does not silence imagination, it guides it. It challenges us to think not of breaking rules, but of bending them in ways that keep reality intact. The very difficulty of the limit fuels the fire of curiosity, pushing explorers to seek paths not of defiance, but of discovery. The crew stands at the edge of their thought experiment and looks out upon the stars. They see the photons that left their suns long before Earth was born, racing at their ultimate speed across the gulfs of darkness. They see galaxies billions of years distant, their light stretched and softened by expansion, yet still faithful to the same pace. They feel gravity tugging at space-time, guiding those photons along curves, yet never making them falter. Everywhere they look, the barrier is present, shaping, defining, protecting. In this recognition lies a quiet beauty. The speed of light is not a wall in the way of progress. It is the architecture of reality itself. It is the law that ensures the cosmos can exist as a coherent whole, a universe of stars, of time, of memory. To question it is natural, to challenge it is human, but to embrace it is to understand why there is something rather than nothing, why there is order rather than chaos. The ship's journey ends not with the shattering of a limit, but with the acceptance of one. And in that acceptance lies wonder, for the barrier does not close the universe. It opens it, holding it steady, ensuring that it can be studied, understood, and explored. The crew whispers their final reflection. The speed of light is not just a number. It is the foundation of causality, the rhythm of time, the guardian of energy, the partner of gravity, and the measure of the stars. Nothing can pass it, because without it, the universe itself would fall apart. And that truth, far from limiting, is the greatest beauty of all. The crew remains at the edge of their thought experiment, and for the first time their ship feels still, not because motion has ceased, but because understanding has settled. They no longer ask how to break the barrier or how to cheat it. Instead, they ask what it means to live beneath it, to exist in a universe sculpted by its constancy. They realize that the barrier gives meaning to distance. Stars are not simply scattered fires in the dark. They are milestones, each light taking centuries or millennia to reach us. When a photon born in the heart of a star finally meets an eye or a telescope on Earth, it carries with it the weight of time. It is not simply light. It is history, a messenger that has traveled faithfully across gulfs that no ship has yet crossed. To live in such a universe is to live surrounded by ancient voices, each whispering from a different epoch. The barrier also gives meaning to time. Every second we count, every heartbeat, every orbit of Earth around the Sun is measured against the speed of light. Relativity ensures that time is not absolute, that it flows differently depending on motion and gravity, yet it always flows consistently because the constant ties it together. Without that tether, time would splinter into contradictions, and life could not unfold as a sequence. Under the barrier, memory and anticipation become possible. Stories can be told, lives can be lived. The crew sees that exploration itself is given weight by the limit. If the stars could be crossed in instants, then the cosmos would be a neighborhood, easily traversed, stripped of mystery. But with the barrier in place, the gulfs remain immense, and each journey becomes an act of devotion. A probe launched to another star carries with it the patience of generations. A signal sent across light years carries with it the humility of waiting. The barrier ensures that exploration is not casual but sacred, an act that demands commitment and endurance. And in this endurance lies humanity's strength. The crew knows that even bound by the barrier, humanity will not stop reaching. Ships may take centuries, but they will be built. Messages may take years, but they will be sent. The speed of light is not the end of ambition, but its forge. By resisting our desire for shortcuts, it compels us to build carefully, to imagine boldly, to treasure every step forward. The crew understands now that the barrier also binds us together. On Earth, no one is truly alone, because light itself carries presence. Every sunrise, every star in the night sky, every photon that touches us is a connection across space and time. The constant ensures that we are woven into the fabric of the cosmos, never detached, always part of the grand flow. In this realization, their thought experiment transforms into something more than physics. It becomes philosophy. The barrier is not only a law of motion, but a lesson in patience, in meaning, in humility. To live beneath it is to accept that the universe is vast, that journeys will be long, that discovery will demand more than desire, it will demand perseverance. The crew whispers to themselves that this is not limitation but beauty. The speed of light is the poetry of the cosmos, the measure of both distance and destiny. It shapes not only the universe they explore, but the very way they imagine exploration. It ensures that every act of discovery carries with it a story worth telling. And so, as they stare out into the dark, they no longer see the barrier as a wall. They see it as a horizon, one that cannot be crossed in haste, but one that beckons with endless wonder. The ship drifts through the silence of imagination, and the crew prepares for their final reflection. They have crossed every argument, faced every paradox, and tested every dream. What remains is not a challenge to the barrier, but the beauty of its presence. They think of energy, of how the closer they pressed to the speed of light, the more the universe resisted. They think of time, of how it slowed and threatened to halt at the threshold. They think of causality, of how paradox lurked just beyond the wall, ready to unravel meaning itself. Every path they took ended at the same conclusion. The barrier is unbreakable, because it is not merely a rule, but the very shape of reality. They think of gravity, which bends space and time, but never outruns the limit. They think of loopholes, of bubbles and tunnels, possibilities born from imagination, but bound by the same law. They think of universes without the barrier, chaotic and unlivable, where stars cannot shine, galaxies cannot form, and time itself cannot hold. And they think of the question of change, of whether the speed of light might have been different in the dawn of creation. Each thought is a thread, and together the threads weave into a single truth. The barrier is not an obstacle, but the architecture of existence. The crew sees now that the speed of light is more than a number, more than 300,000 kilometers per second. It is the constant that binds space to time, energy to mass, cause to effect. It is the law that ensures the universe is not chaos but cosmos, not noise but story. Every star, every galaxy, every breath depends upon it. And so, instead of lamenting the wall, they honor it. The barrier makes exploration difficult, but it also makes exploration meaningful. It slows the pace of discovery, but in doing so, it ensures that discovery is treasured. It keeps the universe vast, so that wonder never runs dry. It grants patience, endurance, and awe. As their journey ends, the crew whispers the truth they have learned. The speed of light is not a prison, it is the foundation of freedom. Without it, the universe would collapse into incoherence. With it, the universe holds together, inviting us to explore it piece by piece, moment by moment, light year by light year. The last words linger like a beacon in the darkness. The speed of light is not just a number, it is the architecture of reality. Nothing can pass it, because without it, the universe itself would fall apart. And in that unbreakable truth lies the greatest beauty of all.